It's math time with Heinz. It's math time with Heinz. It's math time.
Hi everybody, in this little lesson here, we're going to spend kind of 2 days working on this little idea, and it's a little formula that we're going to get used to, but we're going to play around with a parabola and talk about what a parabola actually is and some cool geometric properties of parabolas. So yeah, we do a little bit of geometry today, but I promise you all you're going to have to do is plug things into a formula. So consider this parabola here. Find the distance from the vertex to the focus, this is a new word, and the turning point, which is the vertex, to the directrix. So we've got two new words here. We've got this point called the focus, and notice the focus lives inside the curve of the parabola. And then we've got the directrix, yep, tricks are for kids, which is a horizontal line. So the focus is a point, and the directrix is a line. And what I want to know right now is what's the different distance from the vertex to the focus? Well, that's 1. And then the vertex down to the directrix. Well, that's also 1. So both those distances there are 1. Let's do this next one now. What is the distance from the focus to 2, 2, and 2, 2 down to the directrix? So what are those distances there? Well, that's 2 and that's 2. They were both 2. What is the distance from the focus? So we're always starting at this focus, going to 4, 5. So what is this distance? And what is this distance? Well, this distance, I know, it's 1, 2, 3, 4, 5. I can count boxes there. I can't count boxes here for the focus to that 4, 5. So I've got to go from 4, 5 to the point 0, 2. Well, hopefully you remember your distance formula. Your distance formula is you're changing x squared, so subtract your x's squared, plus subtract your y squared. The square root of your change in x squared plus your change in y squared. It's the Pythagorean theorem is what I did. If I make a little triangle out of this, it's just the Pythagorean theorem. So 4 squared plus 3 squared, 16 plus 9 is the square root of 25, which is 5. Well, what do you notice? They were both 5. Let's do one more. Find the distance from 610 to the focus. So the focus all the way up to 610 and 610 down. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, that's 10. If I was to take a guess, hopefully you think the guess is going to be 10. If I go from 610 back to the focus there, well, the distance is subtract your x's squared plus subtract your y's squared. Subtract your x's, subtract your y's. 6 squared plus 8 squared, 36 plus 64, get the square root of 100, which is 10. Which we're not surprised about because it's 10. So it appears that the parabola, the distance from the focus to parabola is the same as the distance from the parabola to the directrix. The distance from the focus to the parabola to directrix is the same. So focus to parabola, that distance is the same as parabola to directrix. So what we do is we define a parabola. What we've just done is we've defined a parabola as the set of points equidistant from a point and a line. So between any line and a point, if I want to be constantly equidistant from them, there exists this thing called a parabola, where those distances from focus to parabola down, those distances are the same. So if I pick any point on this parabola here, those two distances that I just drew in are congruent. Focus to parabola is congruent parabola down to the x-axis. So we're going to play around algebraically with how I can create these equations. That's what we're going to do today. And it involves drawing. There's a whole way you can do this with the distance formula, but we're going to use a little formula and be done with it. So sketch a parabola whose focus is the point 0, 7. So there's a lot of drawing we have to do here. 0, 7. And I'm going to label that F because that's the focus. And whose directrix is y equals 3. So this is 1, 2, 3, 4, 5, 6, 7, and I need to go to here to 3. There's my directrix. So first of all, we know where the vertex is. The vertex is equidistant. Equidistant. What's between 7 and 3? What number is between 7 and 3? What's the midpoint of 7 and 3? The vertex is 0, 5. That's important. And now, is this parabola concave up or concave down? Well, the directrix is like an electric fence. The parabola cannot cross through the directrix. The parabola curves away from the directrix. So my parabola looks something like that. So determine the equation of this parabola here. So here's the long way that we do it, is we pick a point called x comma y and find the distance from focus to parabola, parabola to directrix. That's how we would really do this. And I'm going to do this once, and you're never going to have to do this. You're never going to have to do this. So I have the square root of x minus 0 squared plus y minus 7 squared. That's this distance here. Parabola to focus equals, well, I got to figure out what point this is. Well, I know it has a y value of 3, but I don't know the x value. So it's the square root of x minus x squared plus y minus 3 squared. The square roots go away. So x squared plus, make a box. I'm going to do this in my head because, again, you're never going to have to do this for me. Equals, that goes to 0. Make another box. Oh my goodness, Heinz, you really expect me to do this on my own? The y squareds cancel out, and I've got to get y by itself. I've got to get y by itself. So x squared plus 40 equals 8y. Divide by 8, and I get 1/8 x squared plus 5 equals y, which is the equation. And here's the really fast way that we're going to do it. Here's the really, really fast way that we're going to do it instead of me shortcutting all that and making that look awful. The equation is y equals 1 over 4p x minus h squared plus k. So you need two things. First, you need to find the vertex, which we found. The vertex was the point 0, 5. And then you need to find the leading coefficient. And that leading coefficient comes from the focal length. So the focal length is how far apart is the focus from the vertex. How far apart is the focus from the vertex? Well, in this case, it's 2. So P equals 2 in my case here. So the way that you get the leading coefficient is you multiply it by 4 and then flip it. So 2 times 4 is 8, so I end up getting 1/8. So my parabola, y equals 1 over 8, and then it's the vertex. I don't need to go left or right at all. X minus 0 squared up 5. Well, x minus 0 is just x squared, which is the exact same answer we got up above. So we're going to spend the rest of today practicing this, but here's the process. We draw a picture. We do not do the distance formula because that takes way too long. We skip that step there, and we go right to plugging it into this little formula here. You've got to find two things. You've got to find the vertex, and you've got to find the focal length. So let's do one and see how it goes. Determine the equation of the parabola whose focus is 4, 1. So again, we're drawing a picture. 4, 1. I'm going to put a little f there for focus. And whose directrix is y equals negative 3. I like to use a dashed line most of the times for the directrix. So the first thing we need to do is figure out who's in the middle. Who's in between 1 and negative 3? Well, count how many boxes there are. 1, 2, 3, 4. So I got to go 2 and 2. I'm going to label that with a V. That's my vertex. My vertex, all I did was I changed the y value there. What's in between negative 3 and 1? 4 comma negative 1. And I know it's concave up because I can't touch the directrix there. What's my p value? 1, 2. I went up 2 boxes there. And that's it. I'm done. My equation is y equals 1 over 4p x opposite. I need to go right 4 and down 1. Make sure you include that squared there because it's a parabola. So 1 over 8 x minus 4 squared minus 1. That there is that parabola. I didn't have to do any distance formula. It just involved knowing two things. You have to find the vertex, which is equidistant perpendicularly from the directrix and the focus. And then you have to find the focal length by counting boxes. This isn't too bad. This isn't too bad. We can do it. The focus of a parabola has that coordinates. All right, draw a picture. -6, I'm going to label that F, -6, +1. And the directrix is at y equals 4, so 1, 2, 3, 4. So the first thing we do is we get our vertex. Our vertex is in the middle. So how far apart are these? Well, I started at 6, 1, 2, 3, 4. So they're 3 apart from each other. So that means I need to go up 1.5, right? If those are 3 apart from each other, I have to go up 1.5. So 2.5. How did I get 2.5? I added 1.5 to that y value there. Notice I can't be concave up this time because I'd crossed through that electric fence of the directrix. So my leading coefficient is negative. Let's write that down. My leading coefficient's negative because that parabola is upside down there. So what's my p-value? My p-value is, well, what did I add on? 1.5 was that number. So here we go. Y equals 1 over 4p, left 6, so x plus 6 squared plus 2.5. And then finally, what did I say about the leading coefficient? This is the thing you always have to check. It's negative. That parabola opens downwards. So y equals -1/6. I just multiplied that. X plus 6 squared plus 2.5. Good? Hopefully that is good. So again, we find the vertex by finding who's in the middle, and then we find the focal length by seeing how far apart is the focus from the vertex. Well, let's work a little backwards here. The vertex so I'm given the vertex here. The vertex is 2, 4. And the focus is 2, 8. So the focus is all the way up there. Determine the equation of the directrix. So I want to know what is the directrix here. Well, where is the directrix? Focus to vertex. The directrix, well, the parabola goes like that because the focus is always inside the parabola. So that means the directrix is below it. But how far below it? Well, the vertex is in the middle. 1, 2, 3, 4. I traveled 4 there, which means I need to travel 4 more. So the directrix is actually down here at y equals 0. The directrix is y equals 0, or the x-axis. Because those are 4 apart, so the vertex and the directrix also have to be 4 apart. Just for fun, let's write the equation. The vertex is 2, 4. What's my p-value? Focus to vertex is 4. So y equals 1 over 4p. Opposite for your x, right 2, up 4. So the answer is 1/16 x minus 2 squared plus 4. That right there is the equation of my parabola. But again, they wanted the equation of the directrix. They wanted us to work backwards here. I think this is finally, last question of this lesson. Given the parabola here, so I gave you the equation. Well, I don't like this equation because that 5's got to get kicked to the other side. So I'm going to add 5 to the other side, and boom, that's much nicer. I'm going to add 5 to the other side to get this. Well, what do I know about this parabola? Well, think back to the last lesson. We know the vertex is -1, +5. So I know the vertex. The vertex is -1, +5. That's the vertex. I know it's concave down. I know it opens downwards because that negative leading coefficient. And then what do I need from there? Well, I need the focus and the directrix, and that's where that 1/12 comes into play. I wanted a highlighter there. What's your p-value? Well, remember, that's 4p, so p equals 3, right? 4 times 3 gives me the 12. So from the vertex, I need to go up 3, that arrow I drew there is in my way. There we go. And I need to go down, up 3 is going to be my directrix, right? I was at 5, 6, 7, 8. Up 3, my directrix has to be up top because I can't cross through it. So that's y equals 8. And my focus is down 3. There's my focus. What point is that? Down 3, 5, 4, 3, 2. So my focus is the point -1, 2, because I just went down 3 units, that focal length. So again, given an equation, I can find the other two. So I can always give you the vertex, the focus, or the directrix. If I give you 2 of those, you can always find the other one. If I give you 2 of those, I can have you find the other one. So we're going to practice this in class. Hopefully this was a good introduction, though. The key thing is you got to draw a picture, and you've got to know your formula, y equals 1 over 4p x minus h squared plus k. And I'll see you guys in class.